Hello, good evening everyone. My name is Paulos Thomas. I'm a physics lecturer. I'm basically an electrical and electronics engineer, and I have completed my post graduation in power electronics and drives, and right now I am concentrating in my research activities. At the same time, I am taking new NEET JEE classes in online. So what you have to do is that you take a pen as well as a book and copy down whatever you see on the screen. In order to save time, I'll be adding question along with the answer at the same time, and I'll be highlighting and pinpointing it on the screen. Okay, so that we can include more questions. So let's focus to our class today, and if you have any doubts, you can contact me later and give me a feedback after watching the video. Okay, and if you need online class in person, once again you can just ping me, my WhatsApp number. So let's get it done. So this is the first question. Let's discuss the first question. I'm showing you the question as well as the answer together at the same time, just to save time, because so that we can do a lot of problems within this 1 hour. The question is, if current equal to 2 root t ampere, then calculate the average and RMS values over t equal to 2 to 4 seconds. So there are different terminologies like average current, RMS current, instantaneous current, right? Here you can exactly see the average and RMS values they are asking. So once they ask the average and RMS values, what we have to do is, over here you can see current I is equal to, we are integrating. Why we are integrating? Because the current is given as the function of time. Since they have given in the question current as a function of time, we have to integrate the function over time. So integral, the limits they are given, t equal to 2 to 4 seconds. So we have to put the limits over here. Integral lower limit 2 to upper limit 4, 2 root t dt divided by integral 2 to 4 dt. So we know the integration. That part is not a big deal. So t raised to 1 by 2, once you integrate, you get in the numerator t raised to 1 by 2 plus 1 by 1 by 2 plus 1. And you can take this 2 common, where you can take that outside. You get this particular term, which is 4 by 3 t raised to 3 by 2. After that, in the denominator part, it is just integral over dt. Integral over dt is t only within the limits 2 to 4. Applying the limits, you know how to apply limits, which is first substitute upper limit, then substitute lower limit. Upper limit minus lower limit, you get the answer 2 by 3 minus into 8 minus 2 root 2. And that is what the average current is. The RMS current, how will you do that? Root of mean square. That is what RMS, root of mean square. So the same thing you have to do, but inside the root. When I say the same thing, one thing is different, is that you have to take the square of the function, because we are taking the root of the mean of the square, correct, of the current. So once you do that particular step, the same procedure goes on. Okay, now it's integration inside the root. So in the end, you can see that substituting values, and you have to take the root of the final value, you get 2 root 3 ampere. Okay, so simple as that. The question is asking to calculate the average value and the RMS value. This is the step you have to do. Okay, hope it's clear. In this question, the second question, you can see a graph, which is a voltage versus time graph. Okay, this is like a triangular waveform. To be frank, it's, even though it looks like a triangular, we call it a sawtooth waveform. The question is like this: a periodic voltage waveform has been shown in the figure. Determine the frequency of the waveform as well as the average value. Okay, so the two things we have to find is the frequency as well as the average value. Okay, so let's focus on the first part, the frequency of the waveform. So here in the question, you can clearly see here that over here, let me mark that, the first wave is completing after 100 millisecond. Then the second wave is starting after 100 milliseconds, it continues up to 200 milliseconds. So the time period is 100 milliseconds time period. Since they have given time period as 100 milliseconds, then we can jump back to time period equation, which is frequency equal to 1 by time period. Once you substitute that, usually you get the answer frequency as 10 hertz. Now once it comes to average value, they have asked what is the formula. Average value equal to area by time period. So what is the area? Area of this graph, you can see this is a triangle, so you can use the formula half ph, and that's what you are seeing over here, half into base into height over time period. Time period is 100, thus you get 5 volt over here. So the question is to calculate the average value of the voltage. So the answer should be in voltage, right? That's why we are dividing area with respect to time period. What is the area gives you? Area gives voltage into time. Voltage into time over time. So time will get cancelled to get the final answer as voltage. And that's why we have did this calculation over here. Hope you got the concept of this. Anytime a graph is asked, always remember two things. Number one is the slope, second is the area. These two quantities or these two terms have a lot of significance in every single graph. Here also, such a significance, such a importance has come, and that's why average value we are using the area divided by time period formula. Okay. So in this question, they are asking to calculate some quantities. Over here you can see the equation for current is given. We have to find RMS value, peak value, frequency, initial phase, and current at t equal to 0. The first one is they are asking the RMS value. So when they are asking the RMS value, we should know the equation, the general equation of current, right? The general equation of current is I equal to I0 sine omega t plus or minus phi. So with respect to that, here they have given I0 value as 4. Okay, 4. I0 value 4. I0 value means what? Peak value. So directly we are getting the second answer, second question's answer, peak value as 4 ampere. That's what marked over here. So from which you can calculate RMS value. What is the equation for RMS value? IRMS equal to I0 by root 2. So I0 value, maximum value is 4 divided by root 2, you get 2 root 2 ampere. Okay. Now they are asking the frequency part. So we have omega value over here, which is given in the question, which is 100 pi. So from which we can calculate the value of frequency. What is frequency? Frequency equal to 1 by time period. So from omega you can either calculate time period and then you can switch to frequency, or directly from omega itself you can calculate frequency. Why? Because omega equal to 2 pi f, omega equal to 2 pi f, and thus you can calculate the value of f, which is omega by 2 pi, from which you get the answer 50 hertz. Okay. Then comes initial phase. Every time in a sinusoidal function there is a term called initial phase. So there might be a confusion for you then. What is phase and initial phase? Phase is this entire term, okay, 100 pi t plus pi by 3, and initial phase is a pi by 3 term alone, okay, or what we call as phase difference. So this initial phase is that something that differentiate the curves, okay, curves. For example, a voltage curve is drawn. Okay, voltage curve is drawn. Let me mark over here, voltage curve is drawn. Then you want to draw the current curve. Then current curve I am drawing after voltage curve somewhere like this. So this is the initial phase. Okay, the initial phase, when you write the equation for the current, the initial phase becomes this. Why? Because that is a phase difference. We always need a reference, and the voltage waveform is the reference, and the current is lagging by an angle over here, which is pi by 3, and that's why initial phase became pi by 3. Finally, we have to calculate the current at t equal to 0. What is the current at the moment when time is 0? when the moment don't look at this graph, just go to the equation back. Now substitute time equal to 0, t equal to 0. What are you getting the value? We are that's what we call as instantaneous current. So at t equal to 0, you get the current value as 2 root 3 ampere. This current is the instantaneous current. Instantaneous current means current at instant t equal to 0. Hope you understood this question. In this question, let's read out this question. We have a 50 watts 100 volt lamp. Okay, let me mark that first. Is to be connected to an AC mains of 200 volt 50 hertz. Okay, so the specification of the lamp is 50 watts 100 volt. So this should be connected to a 200 volt 50 hertz. So definitely the voltage range is changed. Since the voltage is changed, we have to connect something in series with the lamp. Then only it will work without any issues. Because here we have resistance and we are connecting a capacitance over in series. Then only the total voltage, right? The total voltage should be, or the resultant voltage should be 200 volt. What is the method? V equal to root of VR square plus VC square. V equal to root of VR square plus VC square is the resultant voltage. So right now what we are concentrating is that just see the question. What capacitance is essential to be put in series with the lamp? Okay, so anyways we have to connect a capacitance in series with the resistor, then only it will work without any issues. So first thing we have to do is that we have to calculate the resistance of the lamp, which we have studied in 10th standard. Power equal to V square by R. So R equal to V square by P. We get 200 ohm. Second step is that use Ohm's law to calculate the maximum current. Why? Because the current should not change once you add a capacitor in series with a resistor. The current value, the maximum current value should remain same. And how much is that? It should be 1 by 2 ampere. So how we got that? I equal to V by R. We get half ampere. So that should be the current in this particular series circuit, which should not be changed. Now we are going to connect this particular lamp to 200 volt AC. Okay, just concentrate this particular value, 200 volt AC. So now we have to use the next equation, which is once again Ohm's law. V equal to I times Z. Why we are using this Z? Because this circuit contains reactant components like capacitor. Okay, so we have to use or rewrite the equation of Ohm's law as V equal to I times Z, from which we get Z equal to V by I. The current is half ampere. Okay, we get Z equal to 400 ohm. Now in the case of RC circuit, we know the equation for impedance. At the same time, let me remind you, impedance is equal to 1 by admittance, resistance equal to 1 by conductance. Okay, and what else? Yes, reactance is equal to 1 by susceptance. Let me put K for it for the time being. So these terms you just remember. Impedance equal to 1 by admittance, resistance equal to 1 by conductance, and reactance equal to 1 by susceptance. Okay, now coming back to the question, we have to calculate the value of C only, right? So impedance value we got 400 ohm. Now what about omega? R value we already know, which is 200 ohm. What about omega? Omega equal to 2 pi f. F is given in the question, which is 50 hertz. Substituting the value, solving the equation which I have written over here, you can refer it later. The value you get is capacitance is equal to 9.2 microfarad. What does that indicate? It indicates this resistance and capacitor are connected in series. Okay, the current is as that of the previous case when the capacitor was not connected, which was half ampere, it remains same. So now this resistor, this particular bulb or lamp will work perfectly without any issues. And how it worked? Because we connected a capacitor in series to equalize the voltage of 200 voltage. Hope you understood this question. It's a very easy question. Seeing the graph itself, seeing the circuit itself, you can understand what next should be done. The question is to calculate the impedance of the circuit, which is very easy, z equal to root of r square plus xc square. So why I brought this question over here is because just to make you understand that this term, okay, xc term is called as reactance term. Fine, xc is what called as reactance over here. x equal to 1 by 2 pi fc. X equal to 1 by 2 pi fc, and as we have discussed in the previous case, once you add in a capacitor in series with resistance, that will actually help the bulb or the lamp to work in a higher voltage. Okay, now next thing is that the capacitor, once you connect in series with resistance, what will happen to the current and voltage? So if it is a pure capacitor alone in this circuit, right now this is an RC circuit. If it is a pure, this now includes resistor and capacitor. If it's a pure capacitor, we know definitely that the current leads the voltage. Now here also you can see a resistor is connected in series with a capacitor, right? So the phasor diagram itself will change. So this is, say, voltage VR, voltage across the resistor VR, and this right now over here is current marked in same phase with VR. So we know that the current leads, so this will be VC. So the resultant will be the voltage across resistor and capacitor. Let me mark that once again. I'll show over here. So over here this is voltage across resistance. Okay, now this is voltage across capacitance. Now how you have to solve this? You have to draw or complete it as a parallelogram, and you get the diagonal, which is the voltage diagonal, which is the voltage AC source, voltage of the AC source. So just to bring that idea, and what is a phase? Phase is the angle here, angle formed inside here, and that angle is the voltage between the resultant voltage V and the current. Okay, so this information has to be passed, and that's why I brought this simple question. So what we understood that impedance term equal to root of r square plus xc square, and definitely in an RC circuit, even though the current leads the voltage across the capacitor, the resultant voltage and the current won't be making a 90 degree. It will be making a phi, which I have marked over here. It will be making only an angle phi, which will be less than 90 degree. The reason is because now a resistor has come into place, and that makes a difference. Hope you understood. Thank you. In this question you can see a circuit with inductance and capacitance. So basically we are going to concentrate on an LC circuit. So after watching this particular video about this question, you can see the video about the LC working. So here in this question, if XL equal to 50 ohm and X equal to 40 ohm, calculate the effective value of current in the given circuit. So we know that the impedance we can calculate by using XL minus XC, right? Since there is no resistance term at all, we can directly substitute the value of XL and XC, which is given. So here XL is given as 50 ohm and XC is given as 40 ohm. Substituting, you get the value of impedance. Okay, what is a unit of impedance? Impedance unit is ohm. What is the unit of admittance? Admittance is 1 by ohm. Unit of reactance, it is ohm. Unit of susceptance, it is 1 by ohm. Unit of resistance, it is ohm, and conductance, it is 1 by ohm. So terms like impedance, reactance and resistance, they have unit ohm, where terms like admittance, susceptance and conductance, will be having unit 1 by ohm. Back to the question, here we have to calculate current. So current equal to voltage by impedance. Substituting the values, you get the maximum current, which is 4 ampere. So the question is to calculate the effective value of the current. Whenever a question is asked like that, they are basically asking what is the RMS value of the current. So RMS value you can calculate by maximum value by dividing with root 2. You will get the answer to root 2 ampere. So that's very important. RMS value is the effective heat that can be generated using a DC circuit, DC equivalent circuit. So that is the concept of RMS. So this question, they are asking only the effective value. Instead of directly asking RMS value, they are asking effective value. Okay, this is an LCR circuit. Here you can see a capacitor, inductor and a resistor. This is the capacitor of 1 microfarad, inductor of 10 millihenry and resistor of 10 kilo ohm. We have 4 voltmeters, an AC source, and we have an ammeter. Here you can see the voltage and current both are synchronized, both are in same phase. That's why voltage current waveforms are merged together. Now what I'm going to show you is that I'm going to take off this resonance condition. For that you can change the value of inductance or capacitance. Let me change the value of inductance from 10 millihenry to some other value. What you can see is that the graphs are now unsynchronized. They are out of phase. Where you can see the voltage is the green waveform and current is the, you can definitely see that's a violet color, and it's lagging. Current is lagging voltage. Let me put back that value into our, say, 10 millihenry. You can see the resonance condition is back on. We can change the value of capacitance also in the same manner. You can change the value of capacitance, and thus you can see the voltage and current are out of phase now. Now let me put back that value into our old 1 microfarad. So what happens is that the resonance condition is back. So what is the resonance condition? XL equal to XC. When XL equal to XC, F becomes 1 by 2 pi root LC. Substituting the values of inductance and capacitance, you get the value of frequency, which will be 1591 Hertz, and that's why I have substituted over here, which is 1.59 kilohertz. During this condition, there will be maximum current flowing through the circuit because there is no opposition due to impedance. When there is no opposition due to impedance, the entire circuit now is resistive, and that's why the voltage and current are in phase now. A very simple question. The question is, for what frequency the voltage across the resistance will be maximum? And they have given the inductor value and capacitor value. The inductor value they have given 1 by pi Henry, and capacitor value they have given 1 by pi microfarad. So for what frequency, the question is for what frequency the voltage across resistance will be maximum is what they have asked, which means the answer should be in hertz because they have asked frequency. Now when will that happen? That will happen during resonance. Okay, the voltage across the resistance will be maximum. Why it is so? Because during resonance, voltage across inductance will become equal to voltage across capacitance, and these two terms will get cancel out, and the entire voltage across the source will be across the resistor during resonance. Okay, so what frequency we have to set? We have to set a frequency f equal to 1 by 2 pi root LC. You have seen that in the previous RLC resonance circuit, right? So you get the value of 500 Hertz, which is what they are expecting us to find out. Once again, you can see an RLC circuit. Let's check the question. In this question, we have values, which is inductor value is 40 millihenry connected to an series circuit, right, with a resistance and capacitor, and it is 60 Hertz. calculate the capacitance of the capacitor. We have to calculate the capacitance. If the current is in phase with the voltage, you have to calculate the capacitance of the capacitor. Also, we have to calculate the value of x, which is x over here, and I, which is I here. So you have to calculate these values. By seeing the figure itself, quickly we have to understand that the voltage across the inductor is 300, voltage across the capacitor is 300. Means what? That is the case of resonance, right? It is a case of resonance. When XL equal to XC, it is resonance. Similarly, when VL equal to VC, that is also resonance. So writing the equation XL equal to XC condition, calculating the value of capacitance from it very easily because we know all other values. Omega is 2 pi f, where f is given, which is 60 hertz. Okay, you can substitute that and you can find the value of capacitance, which is 176 microfarad. Then we have to calculate this x volt. X volt means voltage across resistor. During resonance, the entire voltage 110 will be dissipating over the resistance itself. Why? Because there is no effect due to inductance or capacitor. There is no effect. It will act just like a short circuit, and the entire voltage will be dissipated across the resistor. So that x value will be 110 volts. So the total current flowing will be 110 volt divided by 220 ohms will be 0.5 ampere. The total opposition will be due to resistance alone. Okay, in a resonance condition, the total opposition will be due to resistance alone. There is no effect of inductance, there is no effect of capacitor. Even though they are physically there, the effect will be null. Okay, this is a very serious question. Why? Because this is the question which contains the term power. So whenever power is coming, along with that another term power factor is coming, the question is very important. Now, from an electrical and electronics engineer's point of view, let me tell, the power factor has got a lot of importance in this particular stream. The question is, a voltage of 10 volts and frequency 1000 hertz is applied to 1 by pi microfarad capacitor in series with a resistor of 500 ohms. Find the power factor of the circuit and the power dissipated. So we should know the formula. Power factor is simple as cos phi. That's fine. Power dissipated is Vrms Irms cos phi. So normally in my online classes, I used to describe about these terms: power dissipated, power factor. Why not sin phi? Why we are taking cos phi? Why not Vrms Rms sin phi? Why not simply Vrms Irms? There are so many things to explain behind that, which I cannot explain all those things over here. As in simple terms, let me tell you the analogy of this power. If you take a Lay's packet, the chips inside it is active power. Active power is what you call as Vrms Irms cos phi. Okay, now there is a gas filled in that particular Lay's packet. You know which gas is that? It's not oxygen. It will get oxidized. It's not carbon dioxide also. Once again, there is oxygen in it, so the chemical reaction will undergo and the food will get damaged. So it's nitrogen gas. Why we are filling nitrogen gas? In order to feel it fluffy, as well as in order not to get oxidized. Okay, now that nitrogen gas is our reactive power. That reactive power term is Vrms Irms sin phi. In plus 2 we don't have to study about a reactive power component. Okay, at the same time, the total power is Vrms Irms. That is the entire Lay's packet. I hope you are getting the concept. So we have active power, we have reactive power, we have the total power. Okay, total power, we call it apparent power. So here what we are focusing on is only on active power. You know the reason why? Because that is what we require. Active power is what we require, and that is Vrms Irms cos phi. Okay, we don't have to bother about reactive power. But then there is a question, Why can't we sell a Lay's packet without the nitrogen gas? You know the reason. The same way we cannot send power from one point to another without reactive power. So reactive power is required. But the machine or the electrical stuffs or loads will not use reactive power or will not dissipate reactive power. Okay, will not dissipate reactive power. In electrical and electronics, load will use active power, and that's why we are focusing on this Vrms, Irms, cos phi. Okay, now the question is to calculate the power factor and the power dissipated. So let's start with the reactance component. Xc equal to 1 by 2 pi Fc. Substitute the value, you get Xc value. Substitute into impedance, you get impedance value. Okay, now power factor cos phi equal to R by Z. From where is that coming? From where is that particular formula coming? So you should know the power triangle. Okay, now the hypotenuse is impedance, the altitude is reactance X, and the base is resistance, and this angle formed is phi. So cos phi equal to R by Z. If you take sin phi, you will get X by Z. But as I said, we have to focus on cos phi alone for the time being, and thus cos phi equal to R by Z, you get 1 by root 2, which is a power factor. So what is the power dissipated? Power dissipated is Vrms, Irms, cos phi, which means the actual power we are using is Vrms, Irms, cos phi, and otherwise you can take Vrms square by Z cos phi and you get the answer. So let me conclude this question with another important point, that in your home you are using active power, you are not using reactive power. Your electrical meter is working based on active power. Even though you are taking the reactive power, you are giving it back to the electricity board. In the case of Kerala it is KSEB, in the case of Tamil Nadu it is TNEB. So from whichever state you are coming from, the electricity board will be getting back the reactive power. So they cannot ask for they cannot ask that in the electricity bill from the consumer, right? So that's exactly, we have more importance on active power, Vrms, Irms, cos phi. Now this is a big question which we can actually cut short into 4 sub-questions. The first main part of the question is an LC circuit with an inductor 20 millihenry and a capacitor 50 microfarad with an initial charge of 10 millicoulomb. Okay, the resistance of the circuit is negligible. Let the instant of the circuit is close to be t equal to 0. So basically we have an inductor and a capacitor along with a switch, and the instant when you turn on the switch, okay, at the instant at which you turn on the switch, it is t equal to 0. So initially the capacitor is charged. Okay, the capacitor is charged, which is 50 microfarad capacitor is charged to 10 millicoulomb. So the energy stored, basically the moment you turn on the switch is the energy stored in the capacitor. So when the first question, if they ask what is the total energy stored initially, that is the energy stored in the capacitor. What is the energy stored in the capacitor formula? Q square by 2C. What is the energy stored in an inductor formula? Half Li square. What is the energy stored in what is the energy dissipated by a resistor? It is I square RT. What is the energy stored in a spring? It is half kx square. What is the kinetic energy? Half mv square. All these formula, they have a relation. Okay, so here half q square by c, you substitute the value, you get 1 joule. Fine, that's the first part of the question. They are asking the natural frequency, which is f value. To get f value, either you can directly substitute f equal to 1 by 2 pi root LC, or instead here they have done omega equal to 1 by root LC. Substituting the values, later you can calculate f value by dividing with 2 pi. The next is, at what time is the energy stored is completely magnetic? That is very important question. So the moment you turn on the switch, correct, the moment you turn on the switch, it is completely electric. So the question is, at what time the energy stored is completely magnetic? We know the equation is Q equal to Q0 cos omega t for the charge. Okay, Q equal to Q0 cos omega t. So here, the moment when Q becomes 0, it is purely magnetic. It is purely magnetic. Now, at what moment it will happen? When Q equal to 0, when Q equal to 0, the cos omega t value becomes 0. The cos omega t value becomes 0. So the cos omega t value becomes 0 means omega t value, in the first case, omega t value becomes pi by 2. Omega t value becomes pi by 2. Omega is 2 pi f, from which you can calculate t equal to, the first case, it will become t by 4. Understood? Omega is 2 pi f, which is 2 pi by t. Substituting for omega 2 pi by capital T, you get small t equal to t by 4. That is the first moment when it becomes completely magnetic. Okay, further you will get at 3t by 4, at 5t by 4, you will get purely magnetic. Understood? So that is the question they have asked. Now, at what time is the total energy shared between the inductor? At what times is the total energy shared equally between inductor and capacitor? That is the last question. During which all times the energy shared between them is completely equal. We know that charge stored in the capacitor is Q0, right? When it becomes Q0 by root 2, okay, energy is shared equally between L and C when charge on the capacitor become Q0 by root 2. So whenever the charge in the capacitor become Q0 by root 2, then the energy is shared equally. So at what time that happens? So you can simply calculate Q0 by root 2. You can substitute for Q, which is equal to Q0 cos omega t, and the same way we have done before, you can calculate the value of time period. How? Q0 will get cancelled, and when will omega t become 1 by root 2? Sorry, cos omega t become 1 by root 2? It becomes during omega t equal to pi by 4, from which you can calculate t. Initially you get t by 8, followed by during 3t by 8 and 5t by 8, you get you get the times at which the energy is shared equally. Okay. പിന്നെ now there might be a confusion in the case how it became Q0 by root 2. So let's come back to this part, which is energy stored in the capacitor, which is Q square by 2C. So in this particular formula, let's take the case Q. When it become Q0 by root 2 only, its square become Q0 square by 2. Okay, then only the energy will be equally shared. So that is why we are taking Q0 by root 2 case. Otherwise we have to take Q0 by 2. No, we have to take here Q0 by root 2 itself. Okay, this is an RC circuit where you can see a resistor. Instead of resistor, I have connected a lamp. there is a capacitor, there is a source, AC source, and definitely you know the current will lead the voltage by exactly 90 degree, and the voltage across the capacitor is green and the current is violet. Pausing it for a moment, you can see that the violet graph is leading the green graph. So the point is very simple. The voltage across the capacitor and the current through the capacitor will be having a phase difference of 90 degree. But in the RC phasor diagram, you might have observed a phase angle phi less than 90 degree. The reason is because there we are taking the resultant voltage and the current. The resultant voltage and the current won't be having 90 degree exactly. Why? Because there is a resistor component there. If there is no resistant component, the current and the resultant voltage will be having 90 degree. Why? The resultant voltage will be equal to the voltage across the capacitor in a pure capacitive network. But this is not a pure capacitive network, this is an RC network. So the voltage across the capacitor and the current flowing through it will be having a 90 degree phase difference, but the resultant voltage as well as the current will not have a 90 degree phase difference. Here what you are observing is the voltage across the capacitor and the current making an exact 90 degree, and that's why the green graph is starting after the violet graph. Okay, so exactly you can see it is starting after 90 degree once the violet graph has started. Hope it's clear. And the last part of today's class is an RL network. Here you can see a resistor and an inductor. Okay, we have a source and the current this time is the green color and the voltage is the violet color. Pausing this for a moment, you can see exactly that the current green is lagging violet after 90 degree. The reason is because the current lags in an inductor by 90 degree. Lags what? It lags the voltage across the inductor, not the resultant voltage. So we have two voltage sources. That's what confuses you. So here the voltage across the inductor is what I am talking about. In an RL network phasor diagram, once again you see a phase which is less than 90 degree. Okay, here for graphical purpose I am showing you the voltage across the inductor as well as the current through the inductor. That will be having 90 degree itself. But when you take the resultant voltage case, and the current, then it will not be 90 degree, it will be less than 90 degree. Hope it is clear and hope you enjoyed today's class. And as I said, please give me a feedback after the class. So have a great time today, and if you have any doubts, just let me know, just ping me back, and possibly according to your comments I will be posting more videos regarding different chapters. So stay tuned. Thank you.